Hello, hello, hello everybody, and a special hello to everyone joining us for the first time. We're going to be looking at the 2002 Euclid contest, question number 8. Typically on a Euclid, 8, 9, and 10 are the really hard ones. I can't remember a year in recent memory where any of those questions, 8, 9, or 10, was anything but written. Okay, so hopefully you've had a chance to try this competition, particularly question 8 that we'll be going through in this video. If you haven't, click the link in the description. You'll get a copy of this contest. You can try question 8 and watch this video. You can try all the other questions. You can even try question 9 and 10 and get ahead of us. I do encourage you guys to try these contests before you watch the videos so you can see where your strengths lie and more just compare your solutions to mine. Okay? So, question 8, as I keep prattling on about, question 8 is a two-parter, and both of them are written. Okay, so we're going to have to keep in mind that we need to justify everything and write it all down. In a soccer league with 5 teams, each team plays 20 games. That is, each team plays 5 games with each of the 4 other teams. Okay. For each team, every game ends in a win, loss, or a tie. The number of wins, losses, and ties for each team at the end of the season are shown in the table. Determine the value of X, Y, and Z. Okay, so only Team E does not have their data input in here. Other than that, we know Team A's wins and losses, and B's, C, and D, all their wins, losses, and ties. Okay, so we just need to finish up this little chart here. Now, first thing I notice, each team plays 20 games, and let's just double check. Team A, 2 plus 15 plus 3 equals 20. Okay. Team B, 7 plus 9 plus 4, that's going to be 20. So the sum of these values should all be 20. 20 games played, either it's a win, a loss, or a tie, but every one of the 20 games comes out this way. And no game can be a win and a tie or anything like that. So first thing I notice, X plus Y plus Z is 20. I'm going to write down my justification for that. So X is the number of games won, Y is the number of games lost, and Z is the number of games tied. That should be all 20 games. So now we have a single equation in 3 variables. That's not enough to solve them. But we'll see if we can get some more information by studying this chart a little bit more. Okay? So, that's studying the chart horizontally, everything just in terms of Team E. But how about we consider the chart vertically? I mean, we would have had this even if we didn't know any of the information about Team B or Team C, but we have all this other information. And the first thing I'm noticing is wins and losses. There's a lot of losses, not that many wins. But if you think about it, and this is where, question 8 does rely a little bit on your knowledge of English, which can hurt recent people coming to Canada trying these competitions if you're not an English or French speaker, and it can even hurt people writing them around the world. But hopefully the translations are good enough for if they're written around the world and translated. But you either win or you lose a game if you don't tie. So I guess what I'm trying to say is every time one team wins, another team must have lost that game. You can't have one team win a game and the other team tie that game. You either have a win matched up with a loss, or you have a tie matched up with a tie. That's the idea. So you have win-loss, or tie-tie, or loss-win, or tie-tie. Okay? So, my thinking is, if I add up all the numbers in the win column, that should equal all the numbers and if you add them up in the lost column. Because for every win, there should be a loss. Okay? And hopefully that should give us, just looking at the chart here, that should give us a little bit of information about how X relates to Y. And then if we need to go a step further, we'll say, okay, well, for every tie there should be a tie, and we might have to figure out how many games were overall played. Each team plays 20 games, but the 5 games that Team A plays with Team B should not be counted again when you consider Team B playing with Team A. Those are the same 5 games. So we might need to get into that. But let's not get ahead of ourselves. Let's write down our justification here. So a game, if it's not tied, results in a win for one team and a loss for the other. You can't have win-win. You have to have win-loss. You can't have loss-loss. The only thing you can have double of is tie. You can have both teams tie. So the total number of wins should equal the total losses. So the wins are, I think Team A won 2, 7, 6, 10, and X. 2, 7, 6, 10, and X. And that's 9 plus 6 is 15, so it's 25 plus X. The losses are much bigger numbers, as I recall. 15, 9, 12, 8, and Y. 15, 9, 12, 8, and Y. 15, 9, 12, 8, and Y. 12 and 8 is 20, plus the 15 is 35, and then we add on the 9. So that's like adding on 10 for 45, but subtracting 1, so it should be 44 plus Y. Okay. So 25 plus X is equal to 44 plus Y. That means X and Y must differ very wildly. We'll just bring the 25 over. 44 minus 25 plus Y. And that is, so 45 minus 25 would be 20, so it should be 19 plus Y. Okay. So if we substitute it into this equation, 19 plus Y plus Z, and now we'll have an equation just in 2 unknowns. So we'll get 2Y plus Z is equal to 20 minus 19 is 1. Oh, okay, well that does it. So we have 20Y plus Z is equal to 1. And if Y is greater than 0, then 2Y is greater than 1, because it's going to be at least 2. Actually, I should say it this way. If Y is greater than or equal to 1, and then 2Y is greater than or equal to 2. It's impossible, because all the X, Y, and Z, all of them are at least 0. You might have 0 wins. You might have 0 losses. You might have 0 ties, but you're not going to have -1 ties. So therefore Y has to be 0. So if Y is 0, then to make this equation satisfied, you have to have Z is equal to 1. And X was 19 plus Y. 19 plus 0, which is 19. So that was actually kind of short. Not complaining. Just unexpected. I thought I'd have to do a little more work. Although I guess it's A part, so maybe B will be a little harder. Okay. So we've got our X, Y, and Z, and we justified everything. We justified that first equation where they're all equal to 20. We justified why the win column has to equal the loss column. We didn't even have to worry about the tie column. Okay. So B part. Prove that it is not possible to create a sequence of 4 numbers a, b, c, d such that the sum of any 2 consecutive terms is positive and the sum of any 3 consecutive terms is negative. Okay. Any 2 consecutive terms is positive, any 3 consecutive terms is negative. So what does that mean we've got here? So well, actually, let's not even do anything right now. Not any 2, but sorry, any 2 consecutive. Any 2 consecutive is positive. Any 3 consecutive. This reminds me of negative. This reminds me of I think a Putnam question. I think there was a Putnam question like this, but it was any 7 consecutive are positive and any 11 consecutive are negative. So I think this is somebody looked at a Putnam and maybe dumbed it down a bit. Although that doesn't help me because I don't remember the solution. Nor should it, because you really shouldn't be trying to write a good Euclid if you can already write a really good Putnam. Putnam's a university level competition and it's very, very hard. So even if I knew a Putnam solution, I shouldn't be using it right here. So let's just investigate this question as is. For those of you who are interested, try looking at searching for Putnam competitions online. You can see how challenging some of the questions really are. So let's try and get a handle on this question. I know there's only 4 numbers, so some of you might be able to just dive right in. But let's see if we could make such a sequence. So just playing around here, trying to get a sense, because if there's a way to prove this wrong, there may be a way to do it that becomes apparent as we try and fill these out. So maybe let's say A is 1 and B is 1. So any 2 consecutive, so that gives us a sum of 2. That's great, that's positive. C will have to make this all negative, so we'll have to have negative 3 there. But then B and C isn't positive. Okay. So let's make B and C positive. We have a 4 there, then 1 and 4, that's still positive. B and C is positive. But A, B, C is now 1 plus 4 minus 3 is 2. So it looks like A will have to be negative. So yeah, let's make him negative 2. That way these guys are still 2. Still have 2 here. Still have 1 here, and then overall we have negative 1. Now D, C and D has to be positive, so it's got to be at least 4. That gives us 1. But now D and B outweigh C way too much. Okay. So let's see if we can place, C seems to be a trouble spot, so let's see if we can place C first. If C's got to be negative, B has to be a bigger positive number. And so does D. So wherever I place my negative, I have to have bigger positives on either side. And that means that overall, I should have a total positive value. Okay. Well, what if C isn't negative? That's possible. So maybe I'm going about this the wrong way. What if C is positive? Let's say C is 1. Well, D and C, maybe we'll make C a big positive number. Maybe we'll make it so big that it outweighs B and D, because we're going to have to have negative overall. So these guys should probably be negative numbers to cancel D out. Or sorry, to cancel C out. So overall, those that's negative, so that's -1, and each of these is 2. So that's great. And now when we try and add in A, well, A is going to have to be positive as well, and we're basically going to have the same argument, but with B in place of C. C has got to be bigger than the negative value of B, and A has got to be bigger than the negative value of B. Okay. So maybe neither B nor C is negative. Maybe they're both positive. Actually, maybe one of them is 0. 0, 1, and then we'll put a -2 here. Well, that doesn't work. Overall, that's negative, but C plus D is negative as well. So I'm starting to get a sense that the numbers B, C are really important here. So let's notice B plus C is positive. So at least one of B or C is positive. And now let's break it into cases. If there are no negative numbers, what happens? If there are no positive numbers, what happens? If there are no... Okay, that's the idea here. And, Okay, so we should probably start writing it up nice and neat. So here's our start of the proof, and we want to start with something. So let's suppose there is a sequence. So suppose we did have numbers A, B, and C, and D. That satisfied the given conditions. What we're going to do is called a proof by contradiction. We're going to assume that the thing they're talking about exists, and then show no matter what we try and do, there's always some sort of impasse, there's some sort of illogical statement that results. And because our only assumption is that there is such a sequence, having every single one lead to a nonsense, an illogical outcome, something like 3 is less than 2 might be an outcome, or something like this, might be something that we're able to deduce. Our original assumption must be wrong. Okay, if you start with just one assumption and you only get gibberish out, garbage in, garbage out, so that thing that you started with, that initial assumption, must be wrong. This is called proof by contradiction. You assume it exists, you show that makes no sense, so your original assumption must be wrong. So we're going to suppose that there is such a sequence, A, B, C, D. Okay. So notice B plus C is positive. Now suppose that neither B nor C is negative. Okay? So they could be 0 or they could be positive, but neither one is negative. We're going to show that this leads to a contradiction. So we're breaking it up into cases. First, we're going to say neither one of them is negative and show that that doesn't work. Then we're going to say, okay, let's suppose that B is negative. Okay? Now, they can't both be negative. So if B is negative, then C's definitely got to be positive. And we'll show that that can't work. And then we'll say, well, what if C is negative? Well, it's the same sort of thing. It's just flipped. It's called symmetry. Okay? So, getting back to it. Suppose that neither B nor C is negative. We know that B plus C plus D is negative. So D is less than negative B. We'll bring this over to the other side. Which way do we want to do this? So we'll say that B plus C is less than negative D. Okay. Now, since B and C are both non-negative, we can see, what was it, that B plus C has got to be bigger than C. It's got to be at least C. Maybe B is 0, or maybe not. Maybe C is 0, who knows. But we have at least this. So combining this statement and this statement, so combining 1 and 2, we see that C is less than or equal to B plus C, which is less than negative D. Adding D to both sides, so C is less than negative D. Adding D to both sides, we get that C plus D is negative. But C plus D should be positive because that's what our sequence has to have by definition. So this is a contradiction. Right? Our sequence tells us we should have one thing, but our math, our logic, says we should have another. So that's a problem. So we have two assumptions here. We suppose that there was a sequence that satisfied the conditions, and we suppose that neither B nor C was negative. So at least one of those assumptions is wrong. Right now, all we can really say is that suppose that neither B nor C is negative is wrong. So now let's suppose B is negative. Okay. Now when we did B is negative, we had to have A and C were both positive enough to outweigh him. But then A plus B plus C should be positive. Okay. So suppose B is negative. We know B plus C is like this. So negative B. No, so B is bigger than negative C. Okay. We also know that A plus B do we want to do plus C or not? So we also know that A plus B is positive. And so by the same reasoning, negative A is less than B. Actually, no. Yeah. Okay. So then negative A is less than B, but B is less than 0. So 0 is when negative a is less than 0. And when you multiply by negative 1, you switch the sign around. Okay, multiplying by negative a switches the sign around. Negative 3 is less than negative 2. Multiplying by negative 1, we don't have this. We've got this. Okay. I don't even need this statement. We know 0 is less than b plus c because it's going to be a positive because those two numbers are consecutive. So 0 is less than, add a to each of these. Fantastic. So now we have a plus b plus c is positive. But that's the sum of 3 consecutive numbers, so that should be negative. This is another contradiction. So now we know we can't have both of the numbers be non-negative. We have to have at least one negative number. It can't be b. And if we said c is negative, we could do the same stuff, except you'll just have b or d has to be positive, and you'll get the same sort of thing. So similarly, if c is negative, we get a contradiction. So the last possibility is b and c are negative. Right? We had none of them negative, and that didn't work out. We had just b is negative, and that didn't work out. We had c is negative, and that didn't work out. And actually, it doesn't really matter. The b is negative case covered both b is negative and c is negative. We still got a contradiction out of there. So no matter where we turned, we had an error, we had something that didn't make sense, we had a contradiction. So our original assumption must be wrong. So no such sequence. Can exist. Okay? We assumed we could have a sequence. We assumed there was. And then we said, okay, look at B and C. We did some experimentation, and the experimentation was actually quite key. Okay? We tried to build a sequence, and we saw, where does it fail? Well, it seemed to fail around the middle numbers B and C. So we said, let's suppose there was a sequence, and let's focus on B and C. And we said the negativity of B and C is sort of what's throwing us off. So we said, suppose there isn't a negative number amongst them. That doesn't work. Suppose B is negative. That doesn't work. Suppose C is negative. That doesn't work. Okay? Well, then there's no room for a negative number in there. None of it works. So our original assumption, the suppose there is a sequence, must have been flawed to begin with. Garbage in, garbage out. We started with something that was nonsense, and that's why we kept getting contradictions. We kept getting nonsense. C plus D had to be negative. C plus D had to be positive. Oh, wait, you got crazy. Okay? So that's how we sort of go through a proof by contradiction, and we had some cases here as well. And ultimately, we came to the conclusion that no such sequence can exist. Okay? So that was a nice little B part for A, or sorry, B part for 8. And there isn't a C part, right? No. So that does it for question number 8. We got 2 more questions to go on this Euclid. We got question number 9, which we'll tackle in the next video, and then we'll wrap up everything with question number 10. So thank you guys for watching, and I'll see you guys next time.